Friends, welcome to e-learning platform of Dr. Bapuji Solanke Institute of Engineering and Technologies Mechanical Engineering Department. I am Sagar Gadkar and we are learning the subject elements of machine design. So we have already started with our fifth unit, that is design of springs. In this session we will continue with the same. So in this session we are going to discuss about some spring terminology. So the figure shows the different positions of the spring when the load is applied. So the basic terminology starts with the solid length. So solid length is denoted by L suffix T. So it is defined as the axial length of the spring which is so compressed that the adjacent coils touch each other. Okay, so here you can see the solid length. So this is our solid length. So here these adjacent coils touches each other. So if there is no gap between the adjacent coils, then it is called as solid length. Okay, so solid length is generally calculated by using the equation Ls is equal to nt multiplied by d. So what is this nt? That is total number of turns. Okay, so here in this figure, suppose generally the spring is made up of circular cross section, that is it is made up of wire. So the cross section of the wire is circular. So this is the cross section of the wire. Okay, so here this is the section. So this is nothing but our diameter of the spring. Okay, spring wire. Now to calculate the spring solid length, here we have different number of cross section, that is such type like this. Okay, so if you add these diameters, that is suppose 1 2 3 4 5 6 7. Okay, so the total solid length of the spring will be this 7 times diameter. Okay, so this 7 is nothing but here as nt, that is total number of turns. Okay, so you can calculate this solid length as nt multiplied by d. Next is free length, which is denoted by LF. So it is defined as the full length of the spring under no load condition. Okay, so when there is no load acting on the spring, the length of the spring is known as free length. So this is the free length of the spring. Okay, so free length is generally calculated using the equation, that is the solid length plus maximum deflection. This is your maximum deflection plus clearance between the adjacent coils. So that is the total clearance. Okay, so here the equation is, that is LF is equal to LS, that is solid length, maximum deflection plus 0.15 times maximum deflection. So here this clearance is taken as 15 times the maximum deflection. So 15 times 6 maximum deflection is nothing but 0.1 times the maximum deflection. So the equation is like this. Next terminology is compressed length. So it is defined as the length of the spring under maximum compression. So when the load is acting on the spring, the maximum length which is in compressed state is called as the compressed length of the spring. Next is spring stiffness, which is denoted by small k. It is defined as the force required to produce unit deflection, or it is the ratio of force per unit deflection. Okay, so where is P is axial force and delta is the deflection of the spring. So unit of the spring stiffness is nothing but Newton. Okay, unit of the spring is, so unit of force is Newton, per deflection is measured in terms of mm. So unit is Newton per mm. Next is spring index. So it is defined as the ratio of mean diameter of the coil to the diameter of the wire. So mean diameter of the coil is nothing but capital D and small d is the diameter of the wire. So the ratio of this capital D to the small d is known as spring index. Next is pitch, denoted by small p. So it is defined as the axial distance between the adjacent coils in uncompressed state. Okay, so generally it is calculated by using the equation P is equal to LF, that is free length, upon NT minus 1, where NT is nothing but total number of turns. Next terminology is active coils. So the coils which are free to deflect under the action of force are called as active coils. Okay, so the spring coils which are deflects freely under the action of load, such coils are nothing but active coils. And last one is the inactive coils. The coils which do not deflect under the action of force are called as inactive coils. So inactive coils are calculated by NT, that is total number of turns, minus N, that is number of active turns, active coils. So this is regarding the spring terminology. If you have any doubt regarding to spring terminology, you can always contact me on this number. Thank you.